Yeah, but there's the rush for AI to replace humans, and especially the juniors. Do you see the impact on the job market in Silicon Valley?
That's absolutely going on. I think that's ill-conceived for a couple of reasons. I don't think it's going to work that way. And if you don't bring on any novices or apprentices, how do you get journeymen and masters 10 years from now? In other words, that's a recipe for going out of business.
Well, it's the same thing that we did with outsourcing, right? And then all of a sudden, you outsource everything, and then you go, okay, I need a power guy, or I need a signal integrity guy, and you can't find those guys. They've gone somewhere else.
You didn't plan them 5 years ago to let them get better and work their way up.
Right. You always assume that, okay, someone else is going to do it, and there's always going to be unlimited supply of that. And Sean, you're right. I mean, bringing on young talent, it should be part of the culture of an organization if they want to get better over time. I mean, we all get stuck in our ways, right? We all get to do, this is the way we've always done it, and this has always worked. And some bright kids come in, and they're looking at it, go, why are you doing it that way? I mean, it's just like, that's great, it's refreshing. They got lots of energy. They'll work forever for a piece of pizza, right? I mean, so if that happens and we don't bring some of this young talent on like that, it's not going to look great. I mean, it's going to look great on a damn Excel spreadsheet when they're looking at the expenses, but go look at that company, fast forward five years or maybe 3 years, see what's going on. It'll be a very different picture. It's the numbers guys, and the investment guys. They're looking at these businesses right now as costs. We can develop whatever we need. We just need to drive the costs down. Well, that's not necessarily true. Sometimes you have to make a huge investment early on to get the technology under your belt so that you can, in future generations, reap the benefits of costs, right? You can't do it from the get-go. We've done this again and again and again. I mean, trying to cut the cost right at the beginning doesn't make any sense to me. I mean, it just doesn't. But then again, I'm not a CFO, so.
I think you made a good point. Newcomers look at things with newcomers' eyes, and they challenge established practice.
Yeah.
And maybe 70% of the time, 80% of the time, there's good reasons for traditional solutions and they persist. But 10, 20, 30% of the time, people go, the assumptions that held when we put this in place no longer held. And we didn't notice that, right? And I don't know that you can get an LLM to challenge you and say, hey, it seems like some of the assumptions that you're giving me are incorrect, or I want to go check your premises. I want to go check the basic design here. Whereas the new person will go, this doesn't make any sense to me. Now, that's irritating in some ways, but it's that grain of sand you make a pearl out of.
The only thing I was thinking about here was when we used to bring in new guys, right? They'd gone through the school, universities. So they were familiar with new tools, new methodologies, that kind of stuff, because they were learning that in school, right? So my worry here is if these guys are now going to learn all this AI stuff, going through and getting a degree, that may be limiting them in their ability to think outside the box and innovate, right? Use their own kind of what's here, right? Not what's they're being told by this technology. So I think we need to watch for that.
But I think the universities have a challenge there as well. The clock cycle on changes right now is running very fast. Mm-hmm. So if I want to go teach you first year calculus or first year differential equations or a body of knowledge that's been debugged over decades, the college university system works great for that, right?
Yeah.
But in a situation where things are getting obsoleted more rapidly, I think this argues more for an apprentice model. How do we attach these guys that are breaking the trail? How do we attach apprentices to them so that we get some kind of learning dynamic created? And instead, because of this desire for the tall, thin designer or, let's save costs, it's actually the first example of reverse age discrimination I've seen in Silicon Valley in probably 40, 50 years, right? Normally, it's the other problem, right? Where they go, you're too expensive and we can get a junior guy with twice the energy to...
Yeah. We'll give you a sign-on bonus and a BMW.
Yeah. So the apprenticeship thing, I'm not sure quite how to make that work. We've had this long period of kind of zero interest rate kind of paradigm where we got used to things working a certain way. And The organizations that are learning organizations, and again, if we just pick on NVIDIA seems like they're a learning organization. I'm sure there's many others, but they may be able to digest this and move faster. I don't think we're paying enough attention to not the breakthrough, not the guy that gets the first 20x, but how does that become a team that's moving faster or an organization that's moving faster? And that's where more of a focus on methodology and more of a focus on teaching. To your other point, Jeff, I think there's a tension between I want to share what I've learned, and if that's letting me avoid the layoff, there's a perverse incentive not to share. Yeah. And if that's giving my company an advantage, then I may not want to share that with my competitors. So there's these tensions.
Well, I think it's all these issues are common to anything that's early on in terms of paradigm shift, right? So companies, organizations have to handle and address these issues, bringing on new talent, training, bringing on new processes. What's this do for my roadmap, my portfolio? How do I make this technology scalable over time? How does this affect my architecture? How does it affect my organizational structure? Do I have to look at my skills inventory internally now, and I have to go through mass training or get people up to speed? And what does that mean? How do I do that? And what products do I start? It's easy if I'm starting from scratch, but if I've got a current roadmap, do I intercept stuff that's going on right now with this new technology, or do I look at something new, get my legs under that, and drive that back into other programs? And what's the timing behind that, and who does that? Yeah, there's just a whole list of things people need to kind of get their heads around. It's not just about I get this piece of thing called AI, and now I'm going to be magically more productive overnight. I think individuals may be, but I don't think it's going to make you more productive from the overall product level.
So Norbert, what do you see going on? You're in a larger organization. How do you see this getting digested? What do you see going on?
Well, you need to have a deep understanding of the systems, because how do you want to build better systems if you don't know how to build systems to begin with?
Yeah, that's true. God is great. Now we get these tools, and I'm going, tools don't develop product. People develop product, right? This is going to enable you to develop product, but it's still you're developing it, right? You're just using these tools. So yeah, you have to know what you're doing. It's not gonna protect you from that.
Yeah, and there's a thin line between apprenticeship and blindly copying the response of the ChatGPT into the code, like you mentioned. And I think with the rate of change in software, we lost some of that. And how do we make those juniors to want to improve, to be better? Because at some point, we just run out of seniors.
I think the other thing that's going on is early in a new field, the information is kind of fragmentary and contradictory. And so figuring out how to go from this kind of hazy frontier or this jagged frontier to new methods and a reliable way of doing things requires a lot more. That's not something that an LLM is going to help you with, because there's not a knowledge base you can train it on. You've got fragments where mixing the fragments are the way you're going to go forward, and also things that contradict that and things that are blind alleys. I think if you want to teach somebody an established body of knowledge that's been debugged, if I want to teach someone algebra, I can probably get an LLM to do that. But I think you've got to apprentice to people, and where there's this rapid ongoing experimentation, that requires different approaches. You can't Google for that. In some cases, the information's not written down. It's only shared in conversation, or it's actually the result of somebody watching somebody else doing something and having an insight.
So say, I give this agent a challenge and it writes a piece of code for me. Part of the problems we used to have in engineering was reuse, right? So someone would develop some really smart piece of code or smart circuitry, right? And we say, okay, they developed that. Why don't other people in other products use that, right? Why don't they take that stuff that was developed over here and use it in their product? Well, part of the problem was it wasn't packaged in a way that they could use it. So they'd have to go talk to the engineer and say, well, what does this do? Right. And, what's inside this box? And so first of all, trying to get hold of the engineer that first designed it was like almost impossible, because they're working on new stuff now. So they're not going to spend a week telling you about what they did like 5 years ago. And there was no documentation around it. There was no like test cases or whatever. So is this AI thing going to help with that reuse? So if I develop something in AI, will it package it up into a nice little module, and there'd be like a data sheet on what it just did, and there'll be like a test case around what it just did, so people can like reuse that? Is that going to help?
That might.
So again, conversations around that, the design reuse and standardization around that, and how do you kind of get that into the organization culturally, right? So organizations will have internal libraries of stuff, right? And so who manages that, and how do they say, okay, yeah, you did this security thing this way, you did this security thing this way. We're going to use this one over that one because that one's better.
I think the challenge is, so I think you're talking about kind of moving from breakthrough to beaten path. And part of the challenge is that's a negotiation. You've got a bunch of people that are making different breakthroughs, some of which are incompatible with each other or have a different perspective on the problem. What I've seen is the shared methods are normally a negotiated outcome. You need to get it documented, and then people have to look at that and say, okay, here's the strengths and weaknesses of this approach. Yeah. Here's the strengths and weaknesses of this approach. Yeah. And it could be you support multiple methods depending upon the problem domain that you're working in, right? Things that might be fine for front end look very different in the back end, look very different in test development.
Right. But if this AI helps facilitate that, I think that's a good thing.
The way we want to improve, not just make the team smaller.
Business guys are going to drive the businesses. They're going to, they're going to give engineering the amount of dollars they think engineering needs, and it's never enough, right? So an engineer is going to say, well, yeah, I can do this now, but it's going to take longer, or we're not going to come out with the full functionality in 6 months. We're going to come out with 60% because you funded this that way. So that's going to always happen. But I'm trying to figure out, okay, once this is in place, how does engineering become more efficient using this technology? My other concern was about if you have something generating lots of code, who tests all that stuff? I mean, how do they test it? So you don't want AI developing test programs for the code that it generated, right? Because, engineering 101, right? Someone develops a piece of circuit or a piece of code, you may have them write a unit test, but you don't test your own stuff. You just don't have them. So having AI test its own AI is just kind of doesn't make any sense. And it shouldn't make any sense to people that are developing products. So I don't know how all that works. So again, that's another thing people need to wrestle with. You've got a lot of code now being developed very, very quickly. How do you kind of develop test process around that to verify all these new modules work together? They may work on their own, fine, but at the system level, what's that do? And then at the system level, as you know, but you have one or two really lead guys, right? When things going through a build and the build fails, right? At 1 o'clock in the morning because someone checked in a piece of code that broke something and you got all these contentions. Well, then you got to wake up and go through all the logs and look at all this and go, well, that does that to that. So I don't know how AI is going to help there or make it worse, or how people are going to struggle with that. So
a couple quick points. I think if we look at AI more as a tireless intelligence or a diligent intelligence, I think in the break the build case, a simple set of rules could be applied consistently across that. So it's not that you're eating the bottom 20 or 30% of the problem. You're not trying to get the AI to get the breakthrough. You're trying to get it to do the bookkeeping and the basic blocking and tackling. I guess my fear, I've never worked in an engineering organization where somebody stood up and said, this is a great team. We set very high standards, and I want to let you know that a year from now, only 60% of you are going to be here, right? Whereas when you bring in a new sales force, it's kind of implicit that, if you don't make your numbers, you're gone. But engineers are not normally managed that way because they're working in teams, and you can't always trace who contributed what. I mean, there's other ways to do that, but it's a different model. And I worry that this focus on cost reduction is going to prove extremely corrosive for taking the breakthrough from the early guys and actually getting to raise the standard of performance.
Yeah. But don't you think that's going to work its way out in the next, 9 to 12, maybe 18 months? Because people are they're going to come in with a certain business model and they're going to dramatically cut costs, and then they're going to suddenly realize it's not going to work.
I think it's going to take a couple years.
It's going to be painful, right? I mean,
it's going to be very bad.
Yeah. We've been through reductions, not because we've brought them on ourselves, but because things happen in the market and everything else, but they're very difficult. When you get to commit a program to develop a product that you promise to customers or a market, you better size that and put the right thinking behind that up front, because if you don't, you're in for a lot of pain through the whole process. And my concern is, like you've been saying, Sean, the people, and they're putting this lens on costs now that just have no basis in reality, because we have no data to support it.
There's a category of algorithm. It's called greedy algorithms. And essentially, a greedy algorithm means that you look at the choices in front of you and you choose the best one. And you don't look ahead multiple moves. You don't look at the consequences of that. You just kind of take the best thing and keep doing that. Those algorithms work for some kinds of problems. But right now, we're trying to kind of cost cut our way to greatness. We're starting to realize the implications of code base that's been auto-generated, but I don't think we've seen the full consequences of that yet.
Yeah, it's going to take time to play out, right? I mean, hopefully most companies that are trying to bring this on are putting this technology in play right now internally on smaller projects or subsets of projects just to kind of get their feet under this thing until they've ironed it out. Then they'll understand the cost structures and what's needed to use this going forward in their mainstream product line and go from there. But
I don't know how much controlled experimentation there's been done. Organizations that are not used to acting as learning organizations, I think, have been having a lot of problems where the rate of change outside the company has now increased by an order of magnitude, and their internal kind of control structures and monitoring structures aren't set up for that.
I think as far as testing goes, there's also a bigger problem because you can make another AI model to test the code base just to have a different point of view, but someone needs to review that code, some human, and we are just not wired for that. We are wired for writing code, and now suddenly we need to read a lot of it.
Yeah, and understand it,
There's a greater challenge, and having that great, wonderful machine that will output a lot of code, hallucination, it's a real thing. And Sean, you had a great analogy with climbing a mountain. You just don't get there in a single trajectory.
No.
It's just the nature of AI.
Yeah.
And this LLM hallucinations and LLM-induced psychosis, as they call it, is going to be a big thing in 2026. And I think that Mr. Dunning-Kruger would be excited because sometimes the LLM just hallucinates exactly the way you would expect just to validate your worldview. And you get in this loopback cycle where you just reinforce that false belief, validating this distorted kind of thinking.
Do you think, but the companies, they're going to create their own kind of standards and their own learning modules, one for security reasons and two for it's proprietary and three, we've created it, we kind of know what's in it.
Yeah, exactly. And security will be a big part of this. One, the malicious code, and the other one, what does make you protect your software if you build it on top of AI, some mainstream AI provider? What makes them not to steal it and not to just build a thing you have? And from what I've read, it already happened multiple times. You just can't rely on some AI provider.
So if I was running a company and I had to invest in doing my own kind of AI LLMs and stuff like that, I mean, that's going to cost some headcount and some serious investment, right?
And maybe not the AI itself, just data. And maybe running AI on-premise would be the thing. Now everything is in cloud and, what's the guarantee the information you put it there is just not stored somewhere safe?
Well, we were told on social media anything we put out there was our own and no one else would use it. So
they wouldn't lie, would they?
It's safe.
I wonder if there's a pattern match to the web server code. That's now all essentially open source for internet-facing stuff for a variety of reasons. I think the other thing that happened was the big providers had a good enough business, and it would have been obvious if they were stealing from their customers. So they, for the most part, as far as we know, didn't, right? In other words, Amazon hasn't launched 40 other applications that look a lot like applications that formerly were hosted on Amazon, right? But the incentive set that's facing the large model guys, I think, is very different. And I think you're going to see more people running open source models locally for a variety of reasons.
But if they run numbers on what that would take, so say I had to invest to do this internally, I'm sure that's more than just a handful of people, right?
So the basic model can be a barn raising, a group collective project, and then you feeding it your own data privately to extend it. And if I use an open source model and then extend it, then that may not cost $1 billion. There's a lot to play out here, and I think we have at least one round of bankruptcies here before 2030, before we're done.
But it's the same thing, though. At the end of the day, this technology needs libraries, right?
There's going to be a stack. There's going to be a whole stack of things.
And we know that historically, right? I mean, companies create software libraries, they create hardware libraries, standards and everything else. I mean, that's a huge investment, right?
Basically, it's libraries of the skills, and someone put out a skill that is outright malicious, and everyone just included that because everyone else did.
Yeah.
How can you do this if you haven't even validated what's inside?
But I think the other thing, though, that I want to ask, company A, company B, right? They're competitive. They're competitors. And they're using the same tool set. Where's the competitive edge? How does company A become more innovative to company B? If we're using the same libraries, the same tools, the outputs are, in my mind, probably going to be the same, not too different because it's all based on the same thing. So where's the innovation and where do I get competitive advantage?
Well, this is a great question, because what's stopping you from building something like Facebook when you have all the tooling at your hands?
But it turns out that building the Facebook application is not the barrier to the next Facebook. It's the fact that they've got